Hi all the students of Narayana 9th standard. Today here I am in front of you all to discuss the assignment number 22, work power energy. In this assignment, the first question which has been given to you all is a ball is projected vertically down with an initial velocity from a height of 20 meters on a horizontal floor. During the impact, it loses 50% of its energy and rebounds to the same height. The velocity of projection is g is equals to there you have to take g is equals to 10 meter per second square. Now let us go with this solution. Now in this solution, a ball is projected vertically down with an initial velocity from a height of 20 meters to a horizontal floor. During the collision, it lost 50% of energy. Actually, the total energy formula TE is going to be equal to PE plus KE. Now, from this question, your potential energy is going to be mgh plus kinetic energy is going to be half mv square, and that is equals to the total energy. It is somewhat around mgh. After rebouncing, it comes to a certain height, and that is the height which he needs. Now what actually in this question we need is the velocity of projection is the velocity of projection. If you want to calculate your velocity of projection from this question, you will be getting 1 by 2. So 1 by 2 into, you take m common, you will be left over with gh plus half v square, and that is equals to mgh. Let us cancel m and m. You will be left over with half. That is gh by 2 and plus v square by 4 is equals to gh. So if you take your LCM, you are going to get 4 as your LCM. You will be getting 2gh plus v square is going to be gh. So from here, if you multiply, if you send that 4 that side, you're going to get 4g gh. So from here, v square is going to be equal to 4gh minus 2gh. So from here, you're going to get 2gh. So from here, if you observe, if you send that square that side, you are going to get root 2gh. Now when you try to substitute your values, you are going to get root over 2 into, they ask you to take g as 10, height is given as total height is 20 meters, so I am going to substitute 20 over here. So if you are going to calculate this, you are going to get root 400, which is nothing but equal to 20 meter per second. So now from this we can tell that it is first option. So the velocity which is going to be projected is nothing but 20 meter per second. Hope this is helpful for you. Let us go with next question. Right. In this question, a stone is projected vertically up to reach a maximum height. Okay, there is a stone, you throw it up, it reaches to its maximum height. Okay, now the height which it has reached is h. The ratio of its kinetic energy and potential energy at height 4h by 5 will be Okay, let us consider this situation. I'm going to draw it over here. Let us take, this is a stone, you throw it little up to a height h. So the height over here is h, right? So the total energy at this point is going to be mgh. Total energy at a certain height is going to be mgh. Now at some point 4 by 5 of h, 4 by 5th of height, what is the ratio of, I need the ratio of ke is to pe. I need this ratio. Now when I want to find this ratio, let us try to figure the potential energy at this particular point. PE at height 4h by 5 is nothing but mgh, potential energy formula. What is your h over there? H is nothing but 4h by 5. So if you observe clearly, 4 mgh by 5th of energy is being taken by potential energy at this particular height. At this particular height, potential energy is nothing but 4 mgh by 5. Now 4 parts out of 5, that means if you think the total height is 5, in that 4 parts of 5 are potential energy, that is belonging to potential energy, and the remaining energy from here, if you talk about remaining energy, is in the form of kinetic energy. Now what is the rest of the energy which is left over here? Rest of the energy which is left over here is, at this particular point, Ke is equals to, out of 5, 4 is completed, so 1 mgh is still left over out of 5. This is in the form of kinetic energy. Now when you want to find the ratios of this, you will be getting like ratio of Ke by Pe is nothing but 4 mgh by, Ke is, he asked you the ratio of kinetic to potential, right? So kinetic to potential, kinetic energy is 1 mgh by 1 mgh by 4 mgh by 5 is kinetic energy by 4 mgh by 5 gets cancelled, mgh gets cancelled, and you're going to get 1 by 4. So your ratio is 1:4. So kinetic to potential is 1:4. Potential to kinetic is 4:1. So this is how you have to analyze this question. This is a kind of conceptual type of question. So let us go with next question. Right. In this question, two bodies of masses 4 kg and 16 kg are at rest. The ratio of times for which the same force must act on them to produce the same kinetic energy in both of them is. Now in this kind of questions, what you have to do is, they are saying you same kind of energy. Same kind of energy means two bodies of masses, they gave you m1, let us take this is m1 is 4, m2 is 6 kg. They are at rest. The ratio of times for which, the ratio of times they are asking, that means T1 and T2 will think, for which the same force must act on them to produce same kinetic energy in both of them. Let us think the kinetic energies in both of them are same. We will think half m1 v1 square is equals to half m2 v2 square. Now here in this case, first we are having mass. Let us cancel this half and half. We are having m1 as 4 kg into v1 square is equals to m2 is 16 kg into v2 square. Now from here, if you want to get it in the terms of times, you have to get this equation. V is equals to u plus at. V is equals to u plus at. It is in motion, so equation of motion is this one, and acceleration is going to get added up in this freely falling body or vertically projected upwards. Now they said you they are at rest actually, so initial velocity is 0. From here you will be getting v is equals to 80. So your v is given as 80. Now from that we will take this one as 4 into a t1 square, because acceleration is constant in both of them. Now same, that means I mean to say acceleration is same. Now here a t2 square. From here if you are cancelling 4 ones are 4 fours are, you will be getting a also gets cancelled. You will be getting t1 square is equals to 4 t2 square. Now from here, if you send the square of t1 that side, if you want to get t1 is equals to root over 4 t2 square. Now the square and root goes away, you will be getting t1 is equals to 2 t2. So from here if you want to find the ratios of t1 and t2, that means you will be getting t1, you send the t2 this side and you will be getting t1 by t2, which is equals to 2 by 1. So the ratio of these both is nothing but 2:1. So hope this is helpful for you. Let us meet in next assignment. Until then, bye.